Hey guys, how's it going? Welcome to the next video, I guess. Had a couple of requests for different stuff, and one of the ones that I wanted to tackle right now actually took a little bit of time for me to do some research. Got a lot of good feedback on the last couple of videos that I put up, and so I wanted to look into this steel underpinning versus a concrete underpinning type system. So that's kind of what we're going to cover is steel versus concrete underpinning. So my goal is to try and keep it short and concise. I'm long-winded, so we'll see how that works. There is benefits and pitfalls to using both steel and concrete type underpinning, like mini piles, caissons, stuff like that. I'm mostly going to be talking about the mini piles because if you watch the caisson video, I'm a huge fan of caissons. They are probably the best underpinning repair system that you can put in for any and all types of forces that'll be acting on the structure, as long as you do the proper soils investigation, design it properly. They're just usually super invasive and really expensive, but that's the only downside. And when they fail horribly. But those are like the only downsides to it. Aside from that, caissons, dude, all day long, right? But concrete mini piles are generally a little bit more affordable. So I'm going to cover, again, as a brief intro to both the steel and the mini pile systems. Just a brief intro, and then I'm going to talk about how they compare and contrast and what some of those benefits and pitfalls are. So yeah, without further ado, I'm going to start with steel underpinning. There's three types of steel underpinning that we typically talk about, and that's your push piers, helical piers, and concentric piers. Wow, my writing actually got worse since the last time I did. Anyway, so push piers, helical piers, and concentric piers. Big thing to note is that your push piers and your helical piers use the same side loading bracket, side load, which creates that eccentric force, right? Eccentric forces. Your concentric pier, that's actually written so horribly that I'm going to write it again. Concentric, that's how it's spelled. Your concentric piers go directly underneath the footing. So I'm going to draft all of those up, it's adorable. I'm going to draw it in my horrible drawing type to kind of explain these. So I'm going to have your house, and you've got your footing, right? Dude, what am I even doing? I'm doing kind of a side load view. Anyway, so your push piers and your helical piers, I said, used a side loading bracket, right? So what that is an L-shaped bracket, right? They cut out the toe of the footing so they can get it directly underneath the bearing wall itself, and they attach this bracket to the underside. Now, a push pier is going to run a solid tube, and it just hydraulically presses this tube down into the ground to not necessarily bedrock, but to competent strata, something where the ground is stronger than the force of the house pushing down, right? And then it will create an upward force and lift. Provides you the best lifting up. I'm getting ahead of myself. So you know I do that. So let's say this is competent strata right here. Probably should have changed the color, but whatever. You've got steel tubing that goes down to competent strata. So it transfers the significant loads eccentrically. I should do that. Eccentrically down, right? So sideways and then down. And it makes it what's called an end-bearing pier. Now, it's important to note that this is not like a friction pier. It's not relying on the weight of the soil here. It has a friction collar down at the bottom, which molds the soil, ideally, molds the soil out of the way. And then the tube itself is free to go down this hole. So you're not relying on the skin friction of the soil, because that can give you some tough challenges later. The idea is to make it end-bearing with as little friction as possible on the way down. A helical pier utilizes the same bracket And instead of embedding directly into competent soil and pushing it down hydraulically, it's got these little blades at the bottom of it. 1, 2, or 3 blades, 8, 10, 12, whatever the configuration is. And it screws into the ground so it can bite into the competent strata. So you get a target depth and a target torque pressure, which is all designed through your engineer, right? And that sort of achieves the stability that you're looking for. So for, gonna get to that in a second. So concentric piers, a little bit different. They don't have to cut the toe of the footing. It makes it easier if you cut the toe of the footing, but you don't have to. Those guys will dig to the underside, and their concentric piers will actually go under the footing as well, but they'll usually put like a channel. I'm gonna have to do a side view. They'll put like a I-beam or a channel beam like that, and then push straight down from underneath the footing. So you don't get this eccentric force, this side loading bracket. You get a straight up and down type thing. So I'm gonna change the view real quick. So I'm gonna hit your plan view. If I've got, let's just say the corner of a home, we're at minus 1.0, minus 0.5, minus 0.5, and I've got piers, 2, that should be red, whatever. So for my push piers and helical piers, you'll drive them down until they hit resistance, till you start to achieve the lift, or till you hit your target depth and torque pressures, right? And then you'll load all of these together, and then you put lift stations on and all this fun stuff. But you load all of these together, and then you'll lift one at a time. You'll lift that to minus 0.5, and then you'll open up that one, and you'll lift all of this up at the same time. So you lift it from where it's lowest up to as level as possible, and that will reduce the damage to the inside of the structure, reduce stresses on the footing, prevent risk of like additional structural damages and all that fun stuff. But I believe the concentric piers can operate the same way as far as the lift goes. But let's go to like the front. Dude, I don't even know how to draw this. So if I've got the front of a house and a footing, right? And then I've notched in my L brackets. We'll make this one a push pier, and we'll make this one a helical pier. Right. So I've loaded these together. I've already pushed this down to depth, right? And I've already screwed this one in. And then they pop these lift stations, should change color. They pop these lift stations up on the top. There's a reason I'm going into all this, I apologize. So they pop these lift stations onto the top, and these stations will now push, switch to blue now, down on the piering system, right? And that's for both helical, ooh, it's dying. That's for both your helical and your push, right? So by creating that downward push on something that's already solid, something that's stronger than the downward force that the building is applying, right? That results in upward movement. This wall is stronger than I am, right? As far as resting or whatever. If I apply enough force, it pushes me away from the wall, right? Doesn't matter that my force is going toward the wall, it pushes me away because the wall is stronger than I am. Think about how a push-up is done the same way. I try to apply force down onto the ground. I'm not pushing the earth away, right? My body's lighter, so my body rises while I do the push-up. It's the same thing here. The earth is stronger than the structure, than the weight of the structure pushing down. So when I push down with these piering systems that were all connected together, right, it creates the upward force in order to create the lift. Magic piers are done the same exact way. Just instead of your side loading bracket, they've got these channels of steel that they usually pop on, because the magic pier itself is just a point loading kind of lift station, right, that lifts up here. So if I were to put a point load on that footing, I'm very, very likely to crack that footing. So they pop in this steel channel, so now it's kind of doing a spread load on that footing, it spreads it out to 3 feet and then the diagonal, right? And then if I have another channel steel over here with another point load, you get it, right? So it spreads it all out and reduces the damage, but that same lift is happening up here and up here, so you're getting the lift that you're looking for. So that's my steel underpinning. It was a whole lot of drawing. I hope you guys follow that. So that was my steel underpinning. Your concrete mini piles, in a recap, same thing. You're going to have a structure. I don't know what's going on with my drawings, guys. I apologize, but it's cool. You knew that before. Your mini piles, they're going to drill down. They're going to pre-drill. We'll just do blue, if blue's still. They'll pre-drill down next to the footing, however deep, right? So you've got your engineer who's going to tell you how deep you need to go, and then you should have a minimum embedment into competent strata or into bedrock or whatever it is, and they'll pre-drill everything down. Now there's different drilling techniques that you can use where you drop a casing inside the hole that you just drilled, or you can leave it as an open if you're not worried about sloughing or anything like that. Casings are probably a whole lot easier for something like this, but that's for drilling techniques and drillers to worry about. By design, you're drilling out this section and you're having your minimum embedment down into the competent strata, right? Then usually you'll drop like a rebar cage inside this, similar to a caisson. And then you'll come back and you'll fill the entire thing with concrete. Now, before you do something like that, or perhaps after, you will also leave a little room there, and you will dowel into your existing footing with a different rebar formulation, and then you'll run steel through this whole open hole, and then as you fill the entire thing full of concrete, you'll also tie all of this together with your concrete. So you get the benefits of a grade beam or extended footing, which is a bigger, beefier footing, sustains more loads and all that fun stuff. And you also get the benefit of getting a deep foundation system to transfer significant loads and perform the long-term stability you're looking for. Though one thing that I have been researching, and I talked to a couple different engineers about, somebody had mentioned in the comments, and if you watch this video, I would love to have a conversation about how you guys did this, but they'd mentioned that, without this part I guess, they did the concrete mini pile thing, and then they put a steel L-shaped bracket like a helical pier or a push pier on, and then used that in order to lift. And now that I literally just drew it, I think what they did is they popped that on and then used the lift station to apply pressure down onto the mini pile that's already down there. But aside from that, I don't really see the mechanism that's used to create a lift unless you use sacrificial jacks up here in this portion, which I suppose could be an L-shaped bracket that goes underneath the footing. But a sacrificial jack that goes underneath here, jack it up and then pour the concrete in and tie everything together, and then you can kind of level out that structure, right? So they both have their applications, their benefits, their pitfalls. When do you use push piers steel underpinning versus like mini pile underpinning? If you're not talking specifically just like price and time frame, right? Well, we'll talk about that too, I guess. If you have a highly expansive clay soil, this is clay, silt, rocky, sandy. There's, most types of soil. If you have a particularly dense layer of soil that is not bedrock, let's say you do a geotech investigation and you find that the soil at 4 feet deep is just super strong, right? But below that is super weak, and actual bedrock is, we'll call it 20 feet down, right? 4 feet. So if I pop a push pier onto this guy, and I try to drive through this 4 feet, there's a possibility that I'll create lift at 4 feet. Now remember from the old videos, you're supposed to have 10 feet of unrestrained fill, right? So technically by building code standards, this is floating in the air. It's not even underneath the house. So that's not building code compliant, right? And you could try to pre-drill down through that 4 feet and then run your tubes through. We've done that a few times up in the bay area where you just have like bay mud, which has like 0 strength whatsoever. And you end up pushing your piers like 110 feet in certain areas. But when you have a solid layer and you get lift early and you know you're supposed to be going down 110 feet, you can pre-drill through that layer and then like tack weld your steel tubes together so they don't like slip off and fall while you drive them down. A bunch of wild different ways to do that. But even when we did stuff like that, it was the building department that had us fill our pier tubes with concrete after we were done, which essentially creates a mini pile. But they were worried about the rigidity of the steel at 110 feet deep and how that would affect the whole overall structure and system. So that was kind of where that went. But limitation of push piers. If you had a dense layer, it's the same thing if you've got, I said rocky, but I meant cobbles. Let's say at 8 feet I've got cobbles, right? And my design depth is, still say 20 feet for my helical piers. Well, when I'm trying to screw these things in, these blades, especially the bigger they are, will bite into the rocks. So if you have rocky or cobbly soil, or you've got anywhere that's near a mountain that just has a ton of rocks in the dirt, these blades trying to fight through those rocks don't often help a whole lot. Now there's a couple of manufacturers that make high capacity helical piers. It's like a high torque where they can get through some of them, but I mean, we've run into more than one problem trying to put these blades in the ground where we actually twisted the entire shaft of this solid steel shaft and just rotate and twisted it with all of the torque pressure that we're putting on, trying to fight past some of the soils conditions that we had there. Same problem with push piers you'll have with your concentric piers, but with your mini piles, with your concrete, you start by drilling through the whole thing, right? So you'll have to pre-drill through the existing clay or hard layers or whatever it is that the steel underpinning might be binding up on. And once you drill through, you just drop the cage and do your thing, right? Whether you got the casing in there so you can drop the cage super easy before any of the sloughing comes in, which, again, drilling technique, if you have like sandy or silty soils or something and you drill through it and then you pull your drill out, that hole doesn't stay open, everything collapses inside, and that ruins your entire repair. So in that case, you drop the casing. It's very important. So both processes are relatively quick. The limitation of your steel underpinning is hitting like a false read, so what if this wasn't 14 feet? What if this was like 16 feet down, right? And the target's 20. That would almost be like a false read if it was the same conditions where you were just hitting a hard layer at 16. We just did a job at UC Berkeley where there was a hard layer that we couldn't even push some DI tubes through. And those tubes are, I mean, it's got the tips and you drive and works okay most of the time, but it was a hard layer and we just couldn't get the tubes down, so we wound up having to pre-drill all of those ones as well, right? And that was even for DI. So false reads with your push piers based on the soil types is pretty much one of the biggest things. As far as benefits, pitfalls go, well, I guess that's benefits, pitfalls, but if I were to do a side-by-side comparison, steel, concrete. So steel underpinning, susceptible to hard layer, I'm gonna call it hard layer false. That's what I was just explaining. Where your concentric piers, you pre-drill to target depths. Now for clarity, when you're doing the steel underpinning, part of that thing where I tell people, you need to get a geotechnical engineering report. What's the first step of this entire process? Get a geotech report. I'm having the awesome experience of having one of the houses that I have experiencing subsidence actually right now. And you know what was the first thing I did? Get a geotech report. And it was kind of a fun little back and forth though, because they were able to present to me the soils conditions that were causing the subsidence that I'm experiencing, and I was able to discuss the varying different options for repair, because you know, it's my line of work. So hopefully that's what these videos can do for you guys, provide you enough education where you can go through the repair recommendations and say, hey, does this work, does this not, and kind of get a geotech's opinion on it. But it all starts with a geotech report, because they will tell you about, I was about to draw on the drawing that's not there already, because they will tell you about the hard layer of soil that perhaps your push piers won't go through, or the rocky soil that your steel, your helical piers will bind up on. Just always start with the geotech report, guys. Yes. So hard layer, false read it, hard layers, pre-drill for concrete. So yay, concrete underpinning. As far as price, I think they're pretty cost comparative, but I'm gonna put comparative, cost comparative, asterisk. Love asterisks. So the reason why this one gets an asterisk with your mini piles is because the cost of drilling and dropping your steel cage and then filling up with concrete, that's cost comparative. Don't forget you have to bind everything together with a grade beam, right? You got to tie the concrete into a horizontal concrete beam in order to tie your entire system together. While that does jack up the price a little bit and still might be cost comparative with your steel underpinning at that point, start thinking about like landscaping or concrete pathways around your house, or if you're doing this work on the inside of your house where this now affects your slab. Now you're affecting a whole lot more like ancillary things, and there's not a really fantastic way to handle it aside from just like absolutely ripping up all of your landscaping and hardscaping across the entire scope of work of the area that you'll be treating with your stuff. So there's just not a great way around it, and that'll jack up not only your price for the project, but also the time frame that everything's being handled. So production costs are going to end up spiking, and then you got to worry about like, well, make that my next point. But that's the asterisk for that. They're cost comparative at face value, but once you dive a little bit deeper, it's a lot more inconvenient and a lot more, not a lot more, just generally more expensive for the concrete mini piles. So that's kind of where that one goes. For steel underpinning, there is no spoils. For concrete, there is lots of spoils. So as far as contractor goes, everything that you take out for your steel underpinning, you're generally putting back in. There's not generally a whole lot of like extra dirt or anything afterward. You can smooth everything out, tamp, compact the way that you're supposed to. You can lay concrete over the top and all that fun stuff. If you do have to remove concrete, it's gonna be some spoils in order to get your piers in. It's like a sidewalk or whatever. But by and large, what comes out of the hole goes back in the hole. Versus your concrete mini piles, you're gonna have your excavation costs, and then you're gonna have your hauling costs, and you're gonna have your dump fees and all that fun stuff, because you got to pull all that dirt out. And unless you're going to go spread it somewhere off the side of the road, which would make a lot of people very angry, you got to take that to a dump and get rid of that, right? So you are going to have some hauling fees and some other stuff. So it's a little, you can argue it's a little more environmentally friendly, but advantage, oh, sorry, I wasn't doing this. Cost comparative, even, but asterisk, so they win. No spoils, lots of spoils, they win. Corrosive soil. Doesn't matter. So if you're in a highly corrosive soil and you're putting steel in the ground, you're gonna have to galvanize the steel, make sure, and I mean, lots of the good contractors make sure that all the steel they put in the ground is already galvanized. There's some great companies like Support Works that have like triple hot zinc dipped and galvanized all together. Like, it's really, really good product. You have to do anode bags, or you do something to offset the corrosive soils that may or may not be affecting the steel that's going in the ground. So that would drive up your price. So let me take that away and go back to asterisk on these guys. Because doing stuff like that drives up your price another $100 or whatever per pier. So just thanks. I think ultimately the steel would still be cheaper, but don't know. As far as the concrete, doesn't really matter if you're in a corrosive soil. Doesn't really affect the concrete too much. At least not that I have seen or heard, which is why a lot of people like using the concrete. So if you're in a corrosive soil, dropping any of the rebar that you're dropping down there is going to be encased in the concrete anyway. So extended life expectancy for the concrete mini piles or anything like that. Finally, as far as time frame, the steel is performed in a very short time span usually. Formed in short time frame. Unfortunately for your concrete mini piles, you usually have like concrete curing time and you have to do a lot more excavation, then you have like the spoils you gotta take out or whatever. So generally it takes a little bit longer. So it takes just a little bit longer to do your concrete mini piles, which just takes longer. As far as effectiveness of some other things, I am still an avid believer that your steel underpinning provides the best lifting opportunity. Now, barring using like an L-shaped bracket on top of your concrete mini pile, which I still have never seen done and I figured out during the recording of this video, using the sacrificial jacks with maybe a beam or something on top of your mini piles and the grade beam system that's being tied in can help achieve the lifting that you're looking for. So both of these systems do perform lifting pretty good. Lifting capable is what I'll say. But the best lifting opportunity is generally done through your steel underpinning. There's not a lot of stuff that it can't lift, and unless things go horribly wrong, there's not a lot of things that your steel underpinning isn't gonna lift. And there's been wild projects where we had like a push pier that we were pushing at like 5,500 or 6,000 PSI and this garage was not moving. So things can go wrong, but it's still the best possible lifting opportunity for the steel underpinning. Both systems, I'm also gonna note, are standalone systems. So the way that your steel underpinning is designed, no polymer is required, or no void fill, we'll call it. No void fill is required to fill the hole that you got going underneath, and same here, so I'm just gonna say same. Now for building code compliance for seismic and lateral stuff, you usually do a void fill on it, and if it's a slab on grade and you're lifting it, you gotta do a void fill on the inside of the structure. Again, more for building code compliance, and more is always better, but the way the system is designed is to create like a post and beam system, so it should technically be a standalone system. You don't have to do a void fill inside there as well. So both are standalone systems, both require geotech reports, both should have, well, concrete will probably have a structural, they're both gonna have special inspections. There's no way around any of that. I can't think of anything else, honestly, and this video has gone on too long already. So if you guys can think of anything else, I am, again, more than happy to get some input on any of these videos. Any questions, comments, concerns, you can contact me directly or drop a comment down below. Other than that, if you guys can like, subscribe, and do all the things that I'm supposed to ask you to do, then do that. It'd be good. Thank you, appreciate it.